There's a few more things I want to say about our understanding of the mechanisms of protein synthesis, ribosome structure, and how these things function. And that is, it turns out it has really significant medical implications. And that's because many or most of the antibiotics that we use specifically inhibit bacterial ribosomes. They target bacterial ribosomes and they kill the cells while not interfering with the eukaryotic or our ribosomes. So they're specifically targeting the bacterial ribosomes. Many of them are naturally occurring. In fact, that's how they were often originally identified from fungi. Fungi are eukaryotic organisms. And so they develop these compounds in order to fight off bacterial infections, kind of like an immune system. So specifically inhibiting bacterial ribosomes, that's why we use them for bacterial infections. We cannot use them for viral infections. A lot of times people go to doctors and they have an infection and maybe a viral infection, even like a cold, and so they end up getting an antibiotic, but the antibiotics don't do anything for viruses. It's because viruses infect our cells and use our ribosomes to make more protein, so they're useless for viral infections. But if you look at this table, there's a couple things I want to point out. One is you can see what they do. So tetracycline blocks the A site. Streptomycin, all these are well-known antibiotics. Streptomycin blocks the tRNA initiator methionine entry. Chloramphenicol blocks the peptidyl transferase reaction. Doxycycline also blocks the A site. Erythromycin blocks translocation of the ribosome. Clarithromycin and azithromycin block the peptidyl transferase reaction. Now, the other thing is, these antibiotics have been around forever. There's nothing new here. There's been very few new antibiotics that have been generated. And they've worked well for a long, long time. But now, as we all have probably heard, many of these bacteria are becoming resistant to antibiotics. It's causing huge medical problems. So if you look at tetracycline, it's been around for more than 60 years, and we're still using it. Streptomycin, more than 70 years. And the last two, clarithromycin, and look at the last one, azithromycin, has been around for 40 years. And that azithromycin, they changed the name of it. It's now called the Z-Pak. So when you get the Z-Pak, everybody thinks, oh, this is great. This is a new antibiotic, something new. It's going to work, whatever. Most of the time it does work, but it's a very old product. Well, we're becoming resistant. These things have been used a long time. They've been overused in so many different ways. They're prescribed at times when they don't need to be prescribed, and you end up getting bacteria that evolve to be resistant to these things. They're overused. In many countries of the world, you don't even need a prescription for them. You just go in, you say you're not feeling well, and they give it to you. I was down in Mexico, and you can get them. You can just get the antibiotics. Places like India, you can get them. Lots of countries you don't need prescriptions. So there's zillions of people taking, not zillions of people, zillions of doses out there. They also use it in the cattle industry and in raising chickens. First to try and prevent infections in these organisms, and also with cattle, it turns out that with some antibiotics, what happens is they gain more mass. So they're used at low levels to increase the bulk of the animal to get more meat. But they give them these antibiotics, And so number one, they're in the meat a little bit. Their low doses are in the meat, in the milk, in the chickens that we eat. So we're getting it, and so we end up, the more it's in the environment, you end up selecting for bacteria that are resistant. Also, with these animals, they all the waste products go out into the ground, and the antibiotics are there, and so ultimately organisms that are in the environment also get resistant to these things. So that's one of the reasons. Well, let's look at some of the data. Well, let me just finish that by saying now when you go quite often to stores, people are becoming more aware of this. They don't want antibiotics in their food. So a lot of the meat that you buy, chickens, even eggs, milk, you'll see it'll say antibiotic free, antibiotic free, antibiotic free. So we're moving away from that, rightly so, because it's created enormous problems. So here's some information that comes from a 2019 CDC report basically talking about the threat of antibiotic resistance in the US. So bacteria are becoming more and more resistant. They're creating more and more health problems. Everybody's probably heard of MRSA, or if you haven't, MRSA is called methicillin-resistant staph infection, Staphylococcus aureus. Resistant infections by these staph, and that can be lethal. And what it's shown here in the middle in the dark blue is that there's estimated to be over 2 million resistant infections per year, and that leads to almost 36,000 deaths. 36,000 deaths per year that happen in the hospital due to resistance to antibiotics. And we're running out of antibiotics because they go from one to the next, try the next one, and none work, and there's nothing they can do. There's another illness which is related. It's often called C. difficile. This is a bacteria that often it's in us, but often when you're taking an antibiotic, that these bacteria will kind of grow and then give rise to disease. And they're often resistant to the antibiotic that you're using, and that leads to another 13,000 deaths. So we're having a serious problem with antibiotic resistance in hospitals. People go into hospitals for simple procedures and end up dying because they get a staph infection. And this is showing, and this is methicillin, what I mentioned, the methicillin-resistant staph, which is lethal. And what this is showing, it's a graph between 1982 up to 2002, so it's a little bit old, but it's not getting any better. And it's showing that, if you look at the red, the methicillin, that 60% of infections are resistant in U.S. hospitals. And then vancomycin, which was a new generation, you can see once you start using that, that also starts going up. And what this slide shows is percent of resistant isolates over the course of time, and this goes up to 2010. And line number one is the Staphylococcus aureus. And you can see in 1980, there was very few resistant organisms. And then as time goes on, it goes up. So now we're up to close to 70%. And so all these things are increasing. And so what happens is you get an infection and it's resistant. They try another antibiotic, resistant. They try another antibiotic. No good. And the last one that was the last new antibiotic that came up recently was an antibiotic called colistin, which was thought to be, the deal breaker that it was an antibiotic that seemed to be working really well and with not much resistance, and that turned out not to be that great either. So here it says resistance to the antibiotic of last resort is silently spreading. This was published in 2017. So it says just over a year ago, discovered in China, bacteria that are resistant to colistin are being found all over. So sometimes even the last resort antibiotic, there's nothing they can do. So here's a statement from a couple individuals. So here's the May 2014, very dire statement. A post-antibiotic era in which common infections and minor injuries can kill. Far from being an apocalyptic fantasy, is instead a very real possibility for the 21st century. They're saying we're in big trouble because let me read the second one. That was from the World Health Organization, and this is the CDC director in 2015. What we're seeing really for the first time is an increasing number of people and organisms that are now resistant to every single antibiotic that we have. Now, why aren't there new antibiotics coming off? So the pharmaceutical companies are hesitant. Many of the big pharmaceutical companies are hesitant or actually refuse to work on developing new antibiotics. It's not cost effective, they say. It takes an enormous amount of money to develop new drugs. A lot of chemistry that is involved, a lot of people need to work, a lot of research needs to be done. They have to do animal studies, they have to do all kinds of controlled studies, they have to do clinical trials. It takes a long time, enormous amount of money, and what they're saying is it's not worth it for us because we're not going to make the money back. Because an antibiotic you take for 5 days and that's it. What they're looking for are these blockbuster drugs, which you have, lower cholesterol, you take it for your entire life. That's where they make their money. So there's been a resistance, and so there's very few companies doing it. The government has been trying to give incentives, and I think it's helping a little bit, trying to give incentives to try and develop antibiotics because we need them. So it can be pretty awful. You can die from a simple infection. So I want to tell you about one particular person who's actually a friend of mine. I'll tell you about her in a second. Her name is Amy Copeland. And you may have heard about her because she had an accident a number of years ago. I don't know, 4 or 5 years ago. And she almost died. So this is Amy Copeland. This was taken in 2016. So what happened to her was she was a student, an undergrad at I think it was Georgia State. You can look this up on the internet. I mean, she's well known. She it was spring break, and her and some of her friends. She was very athletic. Her and some of her friends were doing what is it when you zip line? They were doing zip lines across a river in Georgia. It was an old zip line, and she did it once. Everything was fine. She did it again. The zip line broke. She fell into the water and cut her leg. It was a nice gash, but it wasn't anything horrific. And they took her to the hospital to get it cleaned up and sewed up. And then that night she started developing a fever. And the next morning she was in an enormous amount of pain, discoloration of the leg. They took her into the hospital, and they saw it was infected. They tried giving her antibiotics, and they weren't working. It was a staph infection, and then it was spreading, and she went into organ failure. Her kidneys gave out. She was having heart arrhythmia. Her liver was failing. She was dying. And what they did was they started cutting off parts of her body. to save her, the parts that were infected. It would spread through her body. They couldn't treat it. So they completely cut off her left leg. They cut off her, they completely cut off they completely cut off her right leg. You can see it in the chair. Completely cut off her right leg, cut off her left leg below the knee, and she lost both of her hands. And but she lived and she recovered. And this is all because it was resistant to the antibiotic treatment. That's how they saved her life. Now I met her and I know her. She's actually she ended up getting a master's degree in occupational therapy. She's an amazing person. She just bounces back, and I don't get how she has such a positive attitude. But she's become a real advocate for handicapped people, and she has a master's. She works full time as a occupational therapist. She drives a special van where she can control it by different ways. She's getting back into sports. She won a swim meet. She's very athletic. She won a swim meet, like a Special Olympics. She won, first place gold medal. What happened is that a number of years ago, when I heard about what happened to her, it was in the paper and all that. I wanted to talk about when I wanted to talk about the antibiotic resistance. I wanted to mention her story and show some pictures, and I decided that's really not appropriate unless I get her permission. So I was able to get a hold of her phone number, and I called her and we talked, and since then we've been in contact pretty regularly, and she said, no, please do, because I want people to know what's going on. I want people to know how dangerous this can be. I'm more than happy to share my story. Please use my picture, whatever else you want to use. And, whenever I go to Atlanta, not whenever, but often when I go to Atlanta, we have lunch together. Remarkable person. But in any case, this is what happens now. You get a cut on your leg, and you lose half your body. Okay, so we need to find new antibiotics. And there's a few companies, but there is a company that I just want to introduce you to. So this is a company called Melinta. The whole goal of this company is to find new antibiotics based on the structure of the ribosome. So that's their thing. They're committed to finding new antibiotics, and they're using new technologies, X-ray crystallography, looking at the structures of the ribosomes and trying to generate molecules that will inhibit ribosome function. So it says our mission to discover, develop, groundbreaking antibiotics to overcome these resistant, life-threatening infections. So they do X-ray crystallography, or they use information that's in the literature, and they identify where different antibiotics bind. So you can see, where, let's see, if you look on the right-hand side, you can see where tetracycline binds. You can see where streptomycin binds. Hygromycin B is another one. So you can see where they bind. And so what they're trying to do is to look at those binding sites and try and generate new molecules that will bind. And so that's what they're doing, a lot of medicinal chemistry. So here they develop compounds. So there's 3 new drugs that seem to be inhibiting bacterial ribosomes. And you see the structures there. And some of them, what they're doing is they're taking known antibiotics and they're modifying them chemically. So then the bacteria are no longer resistant. They may develop resistance, but at least now they're not. And so that they're showing where these things bind, and these are what the compounds look like. And they actually do have 4 new antibiotics that they were able to put into the market. So here's 4 new products that they have, 4 new antibiotics. called these different names. Some are injectable, some you take, by pills. But the bottom line is that they are working, and there's other companies that are trying to do the same, because we need to develop these things. One of the most dangerous places you can be often is in a hospital, because of the bacteria that are there, and so much of it is resistant that, if you're in a hospital, get out of there as soon as you can. Okay, so we're going to stop here. And what I want to do next is I want to talk more about regulation of translation, because it's another important regulatory mechanism for gene expression. And that'll be in the next presentation.